This exercise is related to bonding structures, structure and bonding, and as well as bond angles. From question 1 to 40 already I have recording, so I'm starting from 41. The first question, which is 41 here. You can also use a chair to state the answer. If any question you think that could be a right answer. So carbon, which is a diamond, and oxygen both form a covalent bond between their atoms. What is the best reason for the fact that the diamond is having a much higher melting temperature compared to that of oxygen? So what might be a reason? Diamond is a solid, but oxygen is a gas at room temperature, but that is not giving any idea about their bonding, because the type of the bonding interaction will decide the melting and boiling point. Diamond is having a giant structure, atomic structure, where oxygen is a simple molecular. So simple molecular, there's a weak intermolecular force or weak force between the particles, wherein a giant structure, because a lot of atoms are there held together by a strong force. That's why B is the right answer. Is it clear? Question 41. That why diamond is having a high melting point than oxygen. Question 42. The bonding in solid ammonium chloride is. So first, we have to draw the structure of ammonium chloride. Ammonium ion means NH4 and chloride Cl. So how the bonds are formed in ammonium chloride? So first we draw ammonium ion. Look, this is ammonia, NH3. That is ammonia. But what happens, because the nitrogen is having a lone pair, so these lone pairs will attract the hydrogen or a proton. So as a result, what it will form? It will form an ammonium ion. So it is having covalent bond, like these are the covalent bonds between carbon and hydrogen, between nitrogen and hydrogen. These three are the covalent bond, and this one is a lone pair, which is used in the bonding. So when both electron pairs are used or involved in the bonding, that type of bond is known as a dative bond. So in ammonium, there is a covalent bond as well as a dative bond. Same thing, there is a chloride ion because it is ammonium chloride. So chloride ion, first it contains 2 electrons, then 8, and then because it's an ion, so it will also have 8, the last shell. The first shell 2 electron. This is a configuration for chlorine, 2, 8, and 7. But 1 electron, because it forms a chloride ion, that means it took 1 extra electron, so there will be a charge of -1. Now there is a negative charge and plus charge. So plus and minus, like what is the force of attraction between the ions? So we call that as ionic bond. So the question is the bonding in solid ammonium chloride. So what are the bonding, or what kind of bonding is there? We can see covalent, that is between carbon and between nitrogen and hydrogen. We see dative, and we see ionic as well, which is between the ammonium ion and the chloride ion. So all type of bonding are there. That's why D is the right answer. Is it clear? Question 42. Any doubt in that? So there is a sharing of electron between nitrogen and hydrogen, that is covalent. There is also a sharing of electron between nitrogen and the other proton, but that is the both electrons are coming from the same atom, so we call that as dative. And because the attraction there is there between the ammonium and the chloride ion, which result in ionic bonding. Question 43. Which of these statements is the best evidence of existence of ions in sodium chloride? So which statement explains the idea that there are ions present in sodium chloride or NaCl? The first statement solid sodium chloride conduct electricity. So ionic compound in solid state cannot conduct electricity because ions are not free to move. That's why A is not correct. When electric current is passed through a solution of sodium chloride, the movement of the colored ions observed. We cannot observe any movement of the ions because sodium ion is colorless, chloride ion is also colorless. So when we are passing a current, we cannot observe any movement of the ions. Ions will move, but we cannot observe the movement of ions. Then part C. So in part C, that sodium chloride crystals have a regular shape. But regular shape does not give an evidence of the existence of the ions. Like it is having a regular shape, but that is not confirmation that there are ions are present in sodium chloride. And in option D, there's a good arrangement between the theoretical and the experimental lattice energy. Lattice energy we always calculate for ionic compounds. When ions are there, the term lattice energy means when ions are there in a gaseous state, form an ionic bond or form a lattice NaCl. In a solid state, we call lattice energy. So when we calculate the lattice energy of sodium chloride, we find that the theoretical lattice energy and the experimental lattice energies of sodium chloride are approximately same. So there's a comparison, like they're very close to each other. So this gives an evidence that when we consider that sodium chloride is an ionic compound and calculate its lattice energy, it matches with the experimental lattice energy. That's why D is the right answer. Is it clear? Question 43. Any doubt in this?
So why it is not C? Means C also is having crystal, means
No.
ionic compounds.
But the thing is, sodium chloride crystals have a regular shape. For example, when you have a, say, diamond is there, diamond is also having a regular shape. So, but that does not give an evidence that it is an ionic compound. Shape of the substance cannot decide its intermolecular force or type of the bonding. So,
Okay, sir, clear.
So ionic compounds have regular shape, but other substances like covalent compound, giant covalent structures also have regular shape. So regular shape is not an evidence of existence of ions. Then which ion is the smallest ionic radii? So to identify the smaller ionic radii, you have to check how many shells are used. So when we check chloride, because chlorine is 17 proton, so chlorine is 17 proton and 17 chloride ion is there, so 18 electrons. For calcium, calcium is atomic number 20 to 20 proton, but a calcium +2 charge, it lost 2 electrons, so it will have 18 electrons. All are isoelectronic. 19 protons for potassium, and because it lost 1, so 18 electrons. And sulfur is there, which is having 16 proton, but -2 means 18 electron. So the smallest ionic radii, which is having greater attraction towards the nucleus. So when we compare, as you can see, in case of calcium, there are 20 protons attracting 18 electrons. So greater attraction is there in case of calcium. So that's why the calcium ion will be the smallest, and which will be large when you check sulfur, which is having 16 protons and 18 electrons are there. So few protons compared to electron, like there is a greater difference. That's why it will be largest. So the question is, which is the smallest ionic radii? That's calcium, or B will be the right answer. In question 45, Which quantity is exothermic? Exothermic means in which energy is released. Atomization. Atomization means energy needed to produce 1 mole of a gaseous atom. So we have sulfur example in a solid state. We have example sulfur in a solid state, we produce sulfur gas. So we have to supply energy to convert solid to gas. So this is endothermic, not exothermic. First, ionization energy. Ionization energy means energy needed to remove electron from a neutral gaseous atom. So when we remove the electron from gaseous atom, it will become plus charge and electron. So we have to supply energy to the sulfur. Like once we supply energy to sulfur, this electron will be removed. So this is also endothermic. First, electron affinity. Electron affinity means it is the energy released when electron is added. Example, you have sulfur and you add electron, so it will form sulfur minus, because when electron is added, the charge will be negative. So first, electron affinity, because it's a bond forming is always exothermic. And second, electron affinity, it will be endothermic. Why? Because sulfur is already charged and we are adding another electron. So we have to supply energy because sulfur is negative and electron also negative. So they repel each other. We have to supply energy so that electron can be added to this sulfur ion. So this will be, so second electron affinity, third electron affinity, fourth, they are all endothermic. The first is always exothermic. So the question is, which quantity is exothermic? So option C is the right answer. Is it clear, this example?
Yes.
Which diagram best represents the electron density in lithium iodide? So lithium is a plus charge. Lithium is a plus charge. And iodine is -1. Now what will happen? That as we know that in ionic compound, ions are not perfect square. Practically what happens, there's a distortion of polarization, and that polarization of a negative ion happens due to the size of the positive ion, size of the negative ion, and the charge on the positive ion. So the distortion will occur for iodide ion. For positive, like electron density of the negative ion shifted more towards the positive ion. So which is the best evidence of ionic compound? Such as if there was no distortion, then ion should be, the electron density map should be like this. But because there will be a distortion, no distortion normally happens for isoelectronic structure, like they have the same number of electrons. So that's why in this case A is the right answer. Which equation represents the lattice energy of magnesium nitride? The definition of the lattice energy, it is energy released when ions in the gaseous state form 1 mole of a compound, 1 mole of an ionic compound. So ions in the gaseous state, like we should have magnesium ion, we should have nitrogen nitride ion. Nitrogen belongs to group 5, so ion will be -3, and it will form magnesium nitride. So to form magnesium nitride, valency and magnesium should be 3 and nitrogen should be 2. So we need 3 magnesium and we need 2 nitride. And the ion should be there in a gaseous state to form a solid. So which one it match with? This one, elements are forming a compound, so it is a formation of magnesium nitride. Here atoms are forming a compound, so that is called bond enthalpy. Here ions are there forming a compound, but that compound in a gaseous state, so that it's not correct. It should be a compound formed in a solid state. When ions in the gaseous state form a compound in a solid state, we call that as lattice energy. And lattice energy is always exothermic because it is bond forming. In which pair are the ions isoelectronic? Means they have the same, the term iso means same. So they have the same electronic structure or same number of electrons. Lithium is having 3 electrons, but lithium plus 3 means it will have 2 electrons. And oxygen having 8 electrons, oxygen minus 2, so it will have 10 electrons. So they are not isoelectronic. Same thing for sodium chloride. For sodium chloride, NaCl, sodium is having 11 electrons. Sodium is having 11 protons and so sodium is having 11 protons and 11 electrons, but it lost one, so it will have 10 here. It will have 10 electrons, and for chloride, 17 protons, 17 electrons, but the chloride ion is there, so 18 electrons. Magnesium, 12 electron, 12 proton, but it is plus 2 charge, so it will have 10. Sulfur is there, 16 proton, 16 electron, minus 2 is there, so 18 electron. We just have to check the electron. Aluminium is 13 electron, 13 protons, so if it is plus 3, it will have 10 electron. Fluorine is having 9 protons, 9 electrons, but fluoride ion is there, so 10 electrons. So aluminium and fluoride ions are isoelectronic because they have the same number of electrons. So for 48, D will be the right answer. In question 49, the following statements are given about the thermodynamic stability of magnesium chloride. Magnesium chloride is stable with respect to chlorine and magnesium, means that magnesium, the stability refers to, like, if it's having a less energy. For example, when we have reactant product, the one which is having less energy, that is more stable. So they mentioned magnesium chloride is more stable compared to magnesium and chlorine. Like if magnesium reacted with chlorine, it will form magnesium chloride, and this MgCl, it is not MgCl2, it is MgCl. So this MgCl, as I mentioned, it is more stable. So if it is more stable, what does it mean? It means MgCl will have low energy and magnesium chloride will have, magnesium plus chlorine will have high energy. So the reactant will have high energy in the product because the stability refers to energy. Low energy for reactant or product means that is more stable. So if we have magnesium plus chlorine gives magnesium chloride. So which kind of energy diagram is this? Endothermic or exothermic? What kind of energy diagram is this? Reactants have high energy and the product is having low energy. Which energy diagram is this?
Exo.
So that's right, it is exothermic. So if it is an exothermic reaction, what will be the enthalpy change, energy change? So it will be negative. So it means the formation, why we are saying it is a formation, because magnesium plus chlorine gives magnesium chloride. So it is a formation. So here it shows that the formation of magnesium chloride is exothermic, so it will be negative. So any answer which is negative, like any option with a negative answer is correct. So either A can be a right answer or C can be a right answer for question 49. Then the next thing, so we work out this should be negative. Then magnesium chloride is unstable with respect to magnesium and chlorine, and the last statement, magnesium MgCl3 is unstable with respect to magnesium and chlorine. Means if magnesium reacted with chlorine, it will form MgCl3, but this MgCl3 is unstable. So this magnesium MgCl3 is unstable. So what does it mean? It means that this MgCl3 is having high energy So this MgCl3 is having high energy, and Mg and Cl will have low energy because they are MgC. As I mentioned, MgCl is unstable. Unstable means high energy. So in this case, the reactant will have low energy and the product will have high energy. So Mg plus 3 by 2 Cl2 gives MgCl3. So reactants have low energy and the product is having high energy. So what kind of reaction is this? This is an endothermic reaction. So endothermic reaction, the enthalpy change should be positive because it is written formation of MgCl3 and this was a formation of MgCl. So formation of MgCl means like when magnesium chloride is formed from magnesium and chlorine, and when MgCl3 means when magnesium and chlorine react to form MgCl3. But from these, the first statement and the third statement, using the first and the third statement, we can work out the sign for enthalpy change of formation of NgCl and MgCl3. So one will be negative, the other one will be positive. So the compound or element or substance which is more stable will have a lower energy in energy diagram, and the substance which is less stable will have a high energy. Is it clear? This question, how we work out the arrow for the sign for enthalpy change of formation or enthalpy change? If you have any doubt or you want me to repeat, just let me know. Question 50. Electrolysis of copper to chromate. The color that develop around the positive anode. So copper to chromate means it contains copper ion, which is +2, and it contains chromate ion CrO4 with a charge of -2. So appearance of copper, that is blue in color. And appearance of chromate, chromate is yellow, dichromate is orange. So chromate is yellow in color. So because the copper is a positive ion, so positive ions, it is attracted towards cathode, the negative terminal. So at cathode, we'll see a blue color movement. And chromate ion, the overall charge of the chromate ion is minus, so it will move towards anode. So if it will move towards anode, what we'll observe? The movement of the color, that will be yellow. So B will be the right answer. So you have to learn the color of these ions such as chromate, dichromate, copper, manganate. Question 51. A chemical compound has a high melting temperature and a high boiling. From this it can be deduced the bonding would be. So there is a chemical compound, it's having a high melting and a high boiling temperature. So what we can conclude from this, or what we can say from this, the type of the bonding within the substance, that its bonding could be ionic but not covalent. So look, even for ionic compounds have high melting and boiling point. Ionic compounds have high melting and boiling point. Covalent compounds can also have high melting and boiling point, depends on the type of the structure, like either it's a giant covalent or a simple covalent. And same thing, metallic substances also have high melting and boiling point. And in the question, they mention a chemical compound. So if they mention a chemical compound, so this option D is not valid at all because metallic bonding is there within the metal. So option D cannot be a right answer. So we have to select either A, B, or C. So A, ionic but not covalent. It might be covalent because covalent can also have giant structure. So if giant structure is there, it will have high melting and boiling point. Covalent but not ionic, again, maybe if it was ionic, it can happen. So option C is the right answer, either ionic or covalent. Either it will have ionic bonding or a covalent bonding to have a giant. Like covalent is there, maybe giant covalent, it will have a high melting and boiling point. So the first statement, a chemical compound, option D is totally removed from that because option D is for metals. Metals have metals have a giant structure for positive ion and the delocalized electron. So in case of metal, it cannot have a metal compound. Metal, if it was a metal compound, then it will be ionic structure, not a metallic structure, or not known as the metallic structure. In question 52, which diagram best represent the electron density map of a chlorine molecule? So electron density map of a chlorine molecule means the covalent structure is there. So there should be one line, like lines around both nuclei. And we can find here C and D cannot be an answer. Why? Because separate lines are there for two atoms. So either A or B. But there should be lines around, even in the center, around the two nucleus. So that's why A is the right answer. Because we can find electron anywhere within this region. Probability of finding electron is maximum anywhere within the region. So for chlorine, A should be the, like any diatomic molecule, even it was not chlorine, if it was oxygen, it was nitrogen, any diatomic molecule, then A should be the right answer. Which is correct for chlorine? First ionization energy. So first ionization energy means, the term ionization energy means energy needed to remove electron. So we have a chlorine atom, we supply energy, it will form a chloride ion and loses electron. So first ionization energy is endothermic. Because we have to supply energy. First electron affinity, when electron, always the first electron affinity means opposite of, you can see both are opposite of each other, like electron here is removed, in affinity electron is added. So when electron is added, here this will be negative, endothermic is there. But electron affinity, when electron is added to neutral gaseous atom, so energy will be released exo. So this is the exo, this one will be endo. So endo and exo, so C will be the right answer. Second electron affinity is always endothermic. In question 54, an aqueous copper to chromate is electrolysis. So copper to chromate is electrolyte. There's a chromate 6 sign is there. The appearance of the copper ion, just we read this, copper is blue in color. Chromate is yellow in color. And this copper to chromate, what is the appearance of CuCrO4? That is a green substance, green compound. So the question is, after 5 minutes, the color observed in the different parts of the solution in a U-tube. So this is a positive anode is there. The negative terminal is a cathode. So the copper ions will move towards the cathode. So at Z, what we'll see a blue color because mostly copper ions are there. And chromate ions, which are yellow in color, attracted towards the anode. So at X, what we'll see a yellow color. And at the center, like where the two ions are, like copper ion and a chromate ion are mixed together, what is the color of that compound? That is green in color. Because from this compound, the ions are separating. So this is green in color. So yellow, green, and blue. So what is the right option? Then D will be the right answer. Is it clear, this question about the electrolysis of copper to chromate? As I mentioned, you have to learn the colors. So this is a structure question. The table shows both the experimental and the calculated values of the lattice energy. Sodium chloride and silver chloride. First, which one is having a strong ionic bond? You can use your mic to state the answer. Which is having a strong ionic bond? Using the value of the lattice energy, 905 and 780. Which is having a strong ionic bond? Silver chloride or sodium chloride? Which one? Sodium chloride or silver chloride? The lattice energy for silver chloride is minus 905, where sodium chloride is only 780. So strength of the bond we can determine by lattice energy. So silver chloride will have a stronger ionic bond as compared to sodium chloride. And then the difference between the experimental value and the theoretical value. So here, how much is the difference? 905 is there and 83, so about, say, 70, about. And this one is only 10. So which one is having a greater polarization? The one which is having greater difference in the theoretical and the experimental value. So silver chloride is also having a greater difference. So it shows that like its ions are not perfect sphere or there's a greater distortion. So the first part, write equation for the lattice energy of sodium chloride and include the state symbol. So when sodium ion is there in a gaseous state mixed with chloride ion in a gaseous state result in a formation of sodium chloride. In a solid state, that will be the lattice energy. Name the energy cycle used to calculate the lattice energy from experimental data. That is called Born-Haber. But this part is actually not in the new syllabus. New syllabus, the Born-Haber cycle, you will study in A2. Before it was in AS. That's why this question is from paper 2016 onward. Explain fully why the experimental and the calculated lattice energies are similar in sodium chloride, where silver chloride they differ significantly. So what is the reason for that? Like why in sodium chloride these lattice energies are similar, but in silver chloride there's a big difference. So what it gives an evidence? It gives an evidence that sodium chloride is perfect ionic or purely ionic. That's why there is a small difference or no difference is there. But what happened in silver chloride is partly or partially covalent. And why it is covalent? Because silver ion polarize the sodium ion. Chloride ion. So when the silver ion polarize the chloride ion, due to this polarization, the distance between the two ions will decrease, so they will become like a covalent, like a sharing of electron. Or you can also mention, like in sodium chloride, there is a small difference in there's a large difference in electronegativity But in silver chloride, there's a small difference. That's why, because small difference, more covalent nature. Greater difference, more ionic nature. So 3 marks. So these 3 points you have to use. Then question 56, which ion has a largest ionic radii? So you will check, this will have 20 protons, 18 electron. This will have 17 proton, 18 electron. This will have 19 proton and 18 electrons, and this will have 16 protons and 18 electrons. So this is same question, same options are there, but before it was the smallest when we highlighted calcium, but now it will be sulfur. So D will be the right answer. The compound with the greatest covalent character. So how to identify greatest covalent character? Greatest covalent character means the one which is having small difference in electronegativity. Remember, electronegativity, it increases as we move across the period, and electronegativity decreases as we go down. So we have the elements which are given. We have sodium, which is a group 1. We have aluminium, we have fluorine, and we have iodine. Now, because greatest covalent character means a small difference in electronegativity. So sodium fluoride, this will be sodium and fluorine. You can see greater gap is there, greater difference. Greater gap means greater difference will be there between them. So greater difference means more ionic nature than covalent. So it cannot be A. Same thing, sodium iodide. Again, they will have, compared to fluorine, there will be smaller difference, but it will have a difference. Aluminium fluoride and aluminium iodide. So aluminium fluoride will have greater difference because fluorine, when we compare the electronegativity, like fluorine is 4, say aluminium, if we take a number, say 2. So 4 minus 2, the electronegativity difference will be 2. But iodine will have a smaller electronegativity, like fluorine is 4, so iodine may be 3.5. So 3.5, and when we subtract, it will be 1.5. So aluminium iodide will have a smaller difference in electronegativity. That's why it will have a greater covalent character, like more polarization or greater distortion. Or you can also remember that the polarization depends on the size of the positive ion should be small, charge on the positive ion should be large, and the size of the negative ion should be big as well. So all these characteristic matches with aluminium and iodine. Aluminium is smaller in size, greater charge, and iodine is larger in size, so it will cause greater distortion. Is it clear? 57, question 57.
Yes, sir.
Yes.
Okay.